Welcome back to Mr. Vaughn's classroom. Before we get started, I'd like to ask you to please hit the subscribe button and give this video a thumbs up. Today, we're in Unit 5, Introduction to Exponential Functions, and we're on Lesson 9, Interpreting Exponential Functions. Our learning goal today is to find some meaningful ways to represent exponential functions. We have two learning targets today. So as we work through the practice problems, please keep these learning targets in the back of your mind. When we get done with the practice problems, we'll come back and review these learning targets, and the goal is for you to feel comfortable making both of these statements by the end of this lesson. Learning target number 1 says I can analyze a situation and determine whether it makes sense to connect the points on the graph that represents the situation. So you need to understand that if we connect the points, then the line that we're drawing, we are saying that every single point on that line makes that function true, which means we are counting all of the in-between numbers for the x category as well as for the y category. So if you're needing it to only be the actual points, then you need to make sure that you don't connect them. Learning target number 2, when I see a graph of an exponential function, I can make sense of and describe the relationship using function notation. So what this means is, if you're looking at a graph of an exponential function, you are able to identify the initial amount by finding the vertical intercept, and you are able to calculate the growth factor by taking the second y value and dividing it by the first y value, and then you're able to talk about where it started and how much it's growing by or decaying by each time x increases. We have one glossary term, and that is exponential function. An exponential function is a function that has a constant growth factor. Another way to say this is that it grows by equal factors over equal intervals. For example, f of x equals 2 times 3 to the power of x defines an exponential function. Anytime x increases by 1, f of x increases by a factor of 3. This means it is being multiplied by 3 each time x increases by 1. Now we can begin the practice problems for Unit 5, Lesson 9. The number of people with the flu during an epidemic is a function f of the number of days d since the epidemic began. The equation f of d equals 50 times 3 over 2 to the power of d defines f. Number 1 asks us, how many people had the flu at the beginning of the epidemic? Explain how you know. So the number in the equation that is by itself tells us the initial amount. So for number 1, 50 people had the flu at the beginning of the epidemic. And again, that's because up here, the number in the equation by itself is your initial amount. Question number 2. How quickly is the flu spreading? Explain how you can tell this from the equation. In the equation, the number that has the exponent is the growth factor. So, the flu is increasing by a factor of 3/2 each day. And again, we know that because the number with the exponent is the growth factor, and that growth factor tells us how much we're multiplying by each time the day increases by 1. Number 3. What does f of 1 mean in this situation? Well, the 1 is in parentheses, and we can see that the d is in parentheses. And d represents the number of days since the epidemic began. That means f of 1 represents the number of people with the flu after 1 day. And number 4, does f of 3.5 make sense in this situation? Well, the 3.5 is in parentheses, and we see that d is in parentheses, and d represents the number of days since the epidemic began. So f of 3.5 represents the number of people with the flu 3.5 days after it began. So yes, it does make sense. So yes, it represents the number of people with the flu after 3.5 days. If you have any questions about how to solve this practice problem, please leave a comment below and I'll get back to you. Our next practice problem says the function f gives the dollar value of a bond t years after the bond was purchased. The graph of f is shown. Number 1, what is f of 0? What does it mean in this situation? Number 2, what is f of 4.5? What does it mean in this situation? And number 3, when is f of t equal to 1,500. And what does this mean in this situation? So the first thing I want to point out are the numbers in parentheses. Anytime we're reading scientific notation, whatever is in parentheses is the input. And we see on the graph, the input refers to the time in years since the purchase of the bond. The other part is any time that we see the function notation equal something. That is going to be the output, and we can see that it is the value of the bond in dollars. So as we answer these, we're going to keep that in mind. So for number 1, we have f of 0. So we are saying the time is 0. So if we go to x is 0 and go up, we find the vertical intercept right here. So f of 0 equals 1,000. As far as what it means, the vertical intercept is referring to the initial amount. So we can say the initial value of the bond was $1,000. And that's how we answer question number 1. Question number 2, what is f of 4.5? Well, again, that 4.5 is referring to the input. So we need to go over until time is 4.5 and then go up. And we have a point right here. And if we look at the numbering, we have 1,000. This would be 1,100, then 1,200. So this point is between 1,200 and 1,300. So this we could estimate to be 1,250. And as far as what that means in this situation, we can say the bond was worth $1,250 after 4.5 years. And that's how we would answer question number 2. And now we have question number 3. On this one, they're doing the opposite. They're giving us the output and asking us to find the input. So if we know the output is 1,500, we go up to where y is 1,500, and we go to the right until we find the point right here. And then we look down and we can see, actually, let me erase this. It actually looks like we might be just a little bit past that point. It looks like this point is right here. So it looks like maybe 8.25 maybe. So I would say f of 8.25 equals 1,500, because we do appear to be just below the line for 1,500 when we're exactly on 8 years. So it looks like we're just a little bit past it. And as far as what that means in this situation, the bond was worth $1,500, approximately 8.25 years after it was purchased. So that is how we can use a graph to answer questions about a function when we are given function notation. If you have any questions about this practice problem, please leave a comment below and I'll get back to you. Our next practice problem says a function f gives the number of stray cats in a town t years since the town started an animal control program. The program includes both sterilizing stray cats and finding homes to adopt them. An equation representing f is f of t equals 243 times 1/3 to the power of t. Question number 1 asks us, what is the value of f of t when t equals 0? Explain what this value means in this situation. So for number 1, f of 0 is going to equal the initial amount. And we see that right here, the number that is by itself. So that means f of 0 equals 243. And in this situation, the function gives the number of stray cats, so that means the town had 243 stray cats when the program started. And that's how we would answer number 1. Number 2, what is the approximate value of f of t when t is 1/2? Explain what this value means in this situation. So what we need to do is, in a calculator, we are going to take 1/3, and then we're going to take that to the power of 1/2, which is 0.5. Now we're going to take that and we're going to multiply it by the original amount of stray cats, 243. And that gives us 140. And since we're talking about cats, we're going to round to the nearest whole number. So for number 2, f of 1/2 is approximately, that's what these little wavy lines that look like an equal sign mean, 140. The town had approximately 140 stray cats after 6 months of the program. And that's how we would answer number 2. Question number 3. What does the number 1/3 tell you about the stray cat population? Well, 1/3, because it's the number with the exponent, that is our growth factor. That tells us how much of the cat population remains after each year. So for number 3, 1/3 tells us 1/3 of the stray cats remain at the end of each year, because our time is being measured in years. And that's how we would answer number 3. And number 4 says to use technology to graph f for values of t between 0 and 4. What graphing window allows you to see the values of f of t that correspond to these values of t? So what they want us to do is use something like the Desmos calculator. And what we're going to do is we're going to type in y equals the 243 original stray cats times 1/3 to the power of x. And now we can see the graph here. And what they wanted was values of x between 0 and 4. So when the graph equals 4, or when x equals 4, y equals 3. So we at least need a y value below 3. And then we can go up to where the vertical axis is, and it should be at our original amount, 243. So if we zoom in here, we'll be able to see that at 0, the y value is 243. So that means to answer our question, a graphing window of 0 less than or equal to x less than or equal to 4. So that means we want x values between 0 and 4, including 0 and 4, and a y value of 3 less than or equal to y less than or equal to 243. Because the value when x was 4, y was 3, so we need to go down at least to that value of y. And we started where x was 0 and y was 243. so we need to go up at least that far. Usually, I will add one onto the left side and one onto the right side, and then one on the bottom and one on the top, just to zoom out a little bit farther and make sure I can see everything. But this graphing window would get us the points that we need. If you have any questions about how to answer this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Our next practice problem says function g gives the amount of a chemical in a person's body in milligrams t hours since the patient took the drug. The equation g of t equals 600 times 3 over 5 to the power of t defines this function. Number 1 asks us, what does the fraction 3 over 5 mean in this situation? Well, we see that 3 over 5 is the number with the exponent. That means it is the growth factor. And in this case, we are talking about the amount of chemical in a person's body after each hour. So this means 3/5 of the chemical remain in the person's body after each hour. That's how we answer number 1. Now number 2 wants us to sketch a graph. So we'll have our y-axis, we'll have our x-axis. We said that the input is the hours. And we said that the y-axis is the milligrams of chemical. And that is starting at 600. It's the number by itself. So that's our initial amount. So now we can go ahead and plot this. We know that the initial amount is 600, so we can put our vertical intercept up here at the top at 0, 600. Now, we know that we are going to multiply that 600 by 3 over 5. Which equals 0.6, and that gives us 360. So after 1 hour, we're down to 360. Now we take that 360 and we multiply it by 3 over 5, which we said was 0.6, And now we're down to 216. So 216. Then we multiply that by 0.6, and we're down to 129.6. And we multiply that by 0.6, and we're down to roughly 78. Times 0.6, and that's going to get us down to 47. And we multiply by 0.6, and that gets us down to roughly 28. And if we multiply by 0.6, now we're down to about 17. So we're just going to keep getting closer and closer and closer to that x-axis. But if you remember, because we are always saying that there is still 3/5 of the chemical left, we will never actually hit 0. So number 3 wants to know what are the domain and range. Well, the domain is all the possible values of x. That is going to start at 0, and it does equal 0, and then it's going to go all the way to infinity, because we're never actually going to hit 0 mathematically. There will always be some tiny decimal fraction left. So we would say less than, and we use the infinity symbol, which kind of looks like a sideways 8. And we put less than because it's impossible to equal infinity. Infinity goes on forever. Now, we look at the range, and we know that the largest value of y that we have is 600. And y has to be less than or equal to y. And then we always get closer and closer and closer to 0, but we never technically hit it mathematically. So we'll use just a less than symbol and say 0. Since we never actually reach it, we're not going to include it. And then they want us to explain what the domain and range mean, and that's what I was stating. So, domain means we start at 0 hours and never mathematically remove all chemical. The range means we start at 600 milligrams and never mathematically remove all chemical. And this again is one of those situations where there is a difference between what is correct mathematically and what is correct logically and reality based. In reality, we would eventually say that this chemical was no longer in our body. Either it actually does completely burn off, or it just gets to an amount that is so incredibly small that we would never be able to measure it. But mathematically, we say this number can never actually hit zero itself because we're always saying there's still 3/5 of what was remaining before. If you have any questions about how to answer this practice problem, please leave a comment below and I'll get back to you with any assistance I can offer. Our final practice problem says the dollar value of a moped is a function of the number of years since the moped was purchased. The function f is defined by the equation f of t equals 2,500 times 1/2 to the power of t. What is the best choice of domain for the function f? So this problem is actually just going to be solved logically, and we're going to solve it by taking a more logical, realistic stance and not a mathematical one. So, mathematically, we see that choices A and B start at -10, and we see that choices C and D start at 0. Mathematically, we could go back 10 years before the purchase of the moped. But in this context, it doesn't make sense to go back 10 years before it was purchased. Because even if you were to think that this wasn't a new moped, you would need to continually double if you were going backwards, because the inverse of 1/2 is 2. So if you tried to double it 10 times, it would become 5,000 after 1 year, 10,000 after 2 years, 20,000 after 3 years. You would get an astronomically high price that realistically a moped would never hit. $2,500 is a realistic purchase price for a moped. So we're going to eliminate A and B because they start 10 years before purchase. So now we're down to either choice C or choice D. Here the difference is how many years you go in the future. And you know that you're dividing this price in half each time you go a year in the future. So, logically and realistically, having a moped for 10 years is probably about as long as you're going to have it before it's not worth keeping anymore. If we wanted to test that mathematically, we could say 2,500 times 0.5 to the power of 10. That brings the price all the way down to $2.44. If we tried to continue cutting it in half for another 90 years, we would be at a very small decimal fraction of a penny. So 10 years is probably as long as we could realistically go. So we'll eliminate choice D because it continues having the moped for 100 years. And that's just not realistic. So C, logically and realistically, is the best choice out of these four answers, even if it may not be mathematically correct. So as we continue going deeper and deeper into math, you have to start thinking more critically about the difference between what is mathematically correct and what is logically and realistically correct in the situation you are being given. If you have any questions about any of the practice problems we've worked on in this lesson, please leave a comment below and I will get back to you. Now, before we finish this lesson, I want to go back and review the learning targets to make sure that you are comfortable with where you're at and that you are on track. Now let's look back over the learning targets. If you are comfortable making both of these statements, then you're right where you need to be. Learning target number 1, I can analyze a situation and determine whether it makes sense to connect the points on the graph that represents the situation. You have to look at the X category and the Y category. If it makes sense to include the values in between the points, then you connect them together. If, however, either of the categories don't make sense to include the amounts in between, then you don't connect the points. Learning target number 2 says when I see a graph of an exponential function, I can make sense of and describe the relationship using function notation. So you need to understand that the vertical intercept of the graph is going to give you that initial amount for your equation. And you need to understand that you can take the second y value, divide it by the first y value, and that will give you your growth factor. And your growth factor is the amount that it's growing by each time, or it is the amount that is remaining each time. And you need to understand how those relate to the specific situation that you're talking about. If you feel comfortable making both of those statements, then you're right where you should be. If you still have any questions about either of these learning targets, please leave a comment below. Before we wrap up, I would ask that if you found this video helpful, please hit the subscribe button and give this video a thumbs up. I look forward to seeing you in the next lesson.